Hello students. Today we will start with unit number 5, and that is the solid geometry. In this particular chapter, we are studying three different objects. One is a sphere, second is a cone, and third is cylinder. So today we will start with sphere. Now here, whenever you define a geometrical object, the definition is very critical, and that definition itself gives you the formula. So how you define a sphere? So sphere is defined as it's a locus of a point whose distance from a fixed point is always constant. So it's a locus of point x comma y comma z, okay, whose distance from a fixed point say a comma b comma c, okay, remains constant. Remains constant, right? This fixed point is called as the center of the sphere. Is the center of sphere, and this constant distance is called as the radius of the sphere. Okay, so now see that this definition itself gives us the how we will calculate the equation of this sphere. Now, okay, so let us see now how this equation of sphere is. So here we have used the simple distance formula. Distance between xyz and ABC, it is equal to the constant distance r. So I have squared both sides and we obtained this. If you simplify the LHS, what you get is okay. So this way, if we simplify the LHS, we will obtain this kind of expression. Now, if you look at the standard form of any second degree equation, the standard form of the equation is like this. Standard form. Okay, so this is a standard form of second degree equation: x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. Now, if I compare this with the equation that we have obtained, what we will get is, okay, now see that 2u is compared with minus 2a, right? So we will get a as minus u. This implies, so I will say this is 1 and this is 2. So I say comparing 1 and 2. Okay, what we will get is a is equal to minus u, right? B is equal to minus v, C is equal to minus w, right? Then you can say r is equal to under root u square plus v square plus w square minus d. Okay, so it is very much clear by just comparing these two equations you will get these things. But remember that ABC is always denoting the center of the sphere, right? So suppose any equation is given to you in this format, okay, in this format, you can easily find out the center and the radius of the sphere, right? So just note these things, okay, and we'll see the illustration. Okay, so now we have, so I say suppose x square plus y square plus z square plus 4x minus 6y plus 8z plus 4 is equal to 0. This is a second order equation given to me. How you will recognize that this is a sphere, that this equation represents a sphere? So there are few what you can say clue for this recognition. What you observe is, first observe that the coefficients of x square, y square, z square, they are same. Coefficients of x square, y square, z square is same. So equal coefficients we have at this. Then there is no term of xy, yz and zx. No term of xy, yz and zx. Right? See, in the equation there is no term of this kind. Okay? And therefore, if these two things are satisfying, we say that the given equation represents a sphere. Okay? And how you calculate its center? So we will just equate this to the standard form. So equate to standard form. So what is the standard form? It is x square plus y square plus z square plus 2ux, 2by, 2wz plus d equal to 0. Okay, and then you can observe what is your u, what is v, and what is w, and what is d. Okay, so I'll note here u is equal to, see, 2u is equal to plus 4, so u will be what? Plus 2. V is equal to minus 6, so it is minus 3, right? 2w is equal to 8, so w is equal to 4, and d is equal to 4. Okay, so now you can see what is the center. Center is minus u minus v minus w. Okay, so the center of this sphere is minus u, so it is minus 2, comma minus v, so it is plus 3, comma minus w, so it is minus 4. And what is the radius? R is equal to under root of minus 2 square, so it is 4 plus 9 plus 16 minus 4 d. So it is u square plus v square plus w square minus d. So if you simplify this, what we will get is 5. Right? So this is a sphere which is centered at this location and its radius is 5. Got it? Okay. You can try some more examples, but this way you can identify a sphere. First of all, note that the coefficients are constant and same. Then there is no term of x, y, y, z and zx. And then by comparing with the standard form, you can easily identify the center and the radius of the sphere. Okay, fine. Then we will see some more problems of sphere in the next video.